In the last lesson, we learned about the basic concept of data storage. In this lesson, we will learn about the development of storage technology together. In this part, we will discuss the development of storage technology from 3 dimensions: architecture, medium, and interface protocol. Just like the saying, long divided must unite, long united must divide, storage technology is the same. Here is an overview of the development of storage architecture. In the traditional storage stage, storage was composed of a single hard disk. This picture is the world's first mechanical hard disk. Its volume is particularly large, almost the size of 2 refrigerators, weighs over a ton, but in fact, its capacity is only 5 megabytes. And at this time, storage was independent of the host, which can be said to be in a state of division. With the development of technology, hard disks became smaller and gradually returned to the interior of the host, which can be said to have restored the state of unity. But subsequently, with the upgrade of storage requirements, storage was once again separated from the host and became an independent device, that is, external storage. The picture is an early product of Huawei's Ocean Store series, external storage or direct attached storage, which is the DAS we mentioned in the last lesson. Its earliest form was JBOD. At that time, it was just a series of hard disks or disks. The full name of JBOD is just a bunch of disks, which means a bundle of hard disks. What the host sees is just a bunch of independent hard disks, which only increases the capacity but cannot improve the security guarantee and performance. By the 1990s, the internet began to spread, and to solve problems such as transmission distance and file sharing, storage networks appeared, or it can be said that networked storage appeared, which is the FAST we mentioned in the last lesson. By this century, distributed storage and cloud storage have become popular storage architectures. Distributed storage can be said to be a specific technology or a specific storage architecture. It builds a storage resource pool by using general server hardware, which is more suitable for cloud computing scenarios. Cloud storage is actually more like a service, such as cloud disks and cloud backups that can be used on the Huawei cloud platform. Next, let's take a detailed look at how the storage architecture has evolved. As mentioned earlier, the earliest storage was composed of a single hard disk. As technology developed and hard disks became smaller, the architecture on the left appeared. That is, the hard disk is inside the server, but this architecture has limitations. For example, the size of our server is fixed and the slots are also fixed, so the expansion of capacity is limited, and in this case, each disk stores data independently and the reliability is relatively poor. And we know that the speed of CPU and RAM processing I/O is relatively high, but in that era, the speed of hard disk processing I/O was not so high. Therefore, the hard disk became the bottleneck of server performance, so external storage appeared. The early external storage looked like the picture in the middle. The appearance of JBOD solved the problem of limited slots to a certain extent, and the subsequent emergence of RAID technology helped solve the problems of reliability and performance. Over time, external storage gradually developed into storage arrays with independent controllers. During this period, dedicated management software could be configured for storage, and what the host saw was a large, high-performance, redundant hard disk. This is the prototype of the storage devices we commonly see today. Of course, today's devices will be more powerful. Whether it's a disk or a disk array, they still belong to the category of DAS, but DAS has limitations. For example, in the DAS era, data was scattered on different devices and the utilization rate of storage space was relatively low. In the process of people using storage devices, some new needs gradually emerged. For example, employees of the same company hope to store the company's business information on a common device for shared access. For example, the increasing height of office buildings makes people hope that the distance between storage and servers can be appropriately extended. As mentioned earlier, in the 1990s, the spread of the internet brought new vitality to storage. Here we can see 2 architectures: storage area network and network attached storage, or what we often call SAN architecture and NAS architecture. SAN architecture forms a regional network between servers and storage arrays, mainly providing cross-storage services. It effectively extends the distance between storage and servers by using the network. NAS devices have a file system and can provide file storage services. NAS devices are connected to servers through a local area network and can connect multiple servers, meeting people's needs for data sharing. Around 2011, unified storage that supports both SAN and NAS protocols quickly became a hot topic, and the trend of integration appeared again. People combined SAN and NAS to provide both database and file sharing services, simplifying storage management and improving storage utilization. The term unified storage is a product of a certain stage. With the development of technology, more and more capabilities are integrated into one device. The concept of unified storage is gradually not mentioned. The popular architecture now is distributed storage, which organizes physical resources through software to form a high-performance logical storage pool. While ensuring reliability, it provides various storage services. The scalability and flexibility of the traditional architecture are limited, but the distributed storage architecture uses general hardware. The architecture is unified, and storage and network are not bound. You can take a look at our diagram. In the distributed architecture, the front-end business network and management network are separated, and the business network and management network are also separated from the back-end storage network. In addition, in a distributed architecture, the performance and capacity of storage can be linearly expanded, resources can be elastically scaled, and flexibility is high. Storage virtualization is an important technical foundation for implementing distributed architecture. It adds a virtual layer between physical resources and clients or servers to manage and control all storage and provide storage services to servers. Using virtualization technology makes the addition, replacement, splitting, and merging of storage hardware completely transparent to servers. It can hide the complexity of physical devices, integrate existing functions of different devices, and help overcome the limitations of the physical capacity of independent storage devices. Cloud storage can use virtualization technology to provide scalable storage resources for enterprises. For users, cloud storage is more like a service provided by cloud service providers. When users use the service through the interface, they cannot perceive the underlying devices and do not care about the management and maintenance of these devices. They are just using these services. Overall, cloud storage has the characteristics of integration, elasticity, and openness. In addition to architecture, the medium of storage is also evolving. The medium for humans to record information, from simple wood and stone, paper to traditional paper tape, and even magnetic tape, has gone through a long process. However, since the appearance of hard disks, the replacement of storage media has accelerated. The first mechanical hard disk was born in the 1950s. As mentioned before, it was very large and had a particularly small capacity. We call this era the era of giant hard disks. With the development of technology, mechanical hard disks are getting smaller, and 14-inch and 8-inch hard disks have appeared. The hard disks in the era of giant hard disks were mainly used in the industrial field. After the hard disk size was reduced to 8 inches, it gradually began to enter the consumer market. By the 1990s, mechanical hard disks could be made very small, which we call micro hard disks. Overall, the capacity of mechanical hard disks is getting larger and larger, but the volume is getting smaller and smaller. Solid-state drives actually appeared very early, and the earliest solid-state drives started with RAM, not the flash medium we are familiar with. RAM is the medium used by early memory sticks. When RAM was just invented, some people started to assemble a large amount of RAM into large-capacity hard drives for sale. Although this medium has relatively good read and write performance, the storage time is limited. In 1967, the floating gate transistor appeared, which is the basis of flash medium. After many years of development, the cost of solid-state drives is getting lower and lower, and the capacity is constantly increasing. Here are some common types of flash media. For SLC, a flash particle can store 1 bit of data. Similarly, for TLC, a particle can store 3-bit data, and QLC can store 4. TLC is a relatively mainstream technology. QLC cannot be rewritten frequently, its performance is worse than TLC and the number of erasable times is less. But its advantage is that the capacity that can be purchased at a unit price is relatively large. It greatly expands the application scenarios of flash memory, making flash memory more suitable for warm data. In recent years, SCM has also begun to appear in people's field of vision. Its full name is storage cloud memory. It is a kind of unconscious storage with better performance than flash memory, slightly worse than cache, fast read and write, low energy consumption, and long life. Overall, people's expectations for solid-state drive-related media are larger capacity and faster speed. If the two cannot be achieved at the same time, they will be carried out separately. With the emergence of faster media SCM and cheaper media QLC, the traditional mechanical hard disk market is further squeezed, and the application scenarios of solid-state drives are further expanded. This trend is thus the flash memory of storage media. The trend of flash memory in storage is not just a change in media. In the process of flash memory, all-flash arrays are becoming more and more popular, and the popularity of all-flash storage has also led to the development of storage interface protocols. Before introducing the development history of storage interface protocols, let's first understand what an interface is and what a protocol is. The hard disk interface is the connecting part between the hard disk and the host system. The function of the interface is to transfer data between the hard disk cache and the host memory. Of course, this host is relative to a hard disk located in the server. For the hard disk in the storage device, the hard disk interface is the connecting part between the hard disk and the controller. Different hard disk interfaces determine the connection speed between the hard disk and the controller. For devices that need to perform data communication, simply connecting is not enough. To complete data communication, it is also necessary to agree on how to recognize each other, how to establish links, how to transmit data, etc. This agreement is what we often call the interface protocol. The interface protocol does not only refer to the protocol of the hard disk interface, but also includes the protocols of other interfaces. There are many types of interface protocols, and each type of interface protocol has different basic specifications and different transmission speeds. This picture introduces the development history of the interface protocol. In the upper half of the picture, it introduces the communication protocol used by the interface, connecting the host and the storage device, while the lower half of the picture introduces the communication protocol used by the hard disk interface. As you can see, for hard disks, the protocols that appear in the left half of the picture, such as SATA, SAS, FC, etc., are all designed for mechanical hard disks. Although these interfaces and protocols can actually be applied to solid-state drives, the access efficiency of solid-state drives is higher. With the popularization of solid-state drives, people urgently need a faster and more efficient protocol to match. Around 2010, the NVMe protocol based on the PCIe interface was born. The NVMe protocol was originally designed based on the PCIe interface, but broadly speaking, storage is not just the hard disk itself, but also includes the network between the host and storage devices. To match the speed performance of all flash devices, a faster network is also expected between the host and storage devices. Hence, NVMe-oF was born. NVMe-oF is the achievement of extending NVMe to the network. Next, let's learn about these two protocols, NVMe and NVMe-oF. The NVMe protocol is the interface standard for SSD controllers, and it is between the controller and the hard disk. It is based on the PCIe interface, specifically designed for solid-state drives. And its goal is to maximize the performance of flash memory. As you can see, compared to the SAS protocol, the NVMe protocol has fewer physical layers.